Hi, and welcome to 3D Across ArcGIS. This is a presentation that we're giving, a technical workshop where we'll be talking about the way in which 3D permeates across the ArcGIS platform, from desktop applications all the way to how we're serving and sharing information over the web. Ultimately, our story here is to discuss how distributed GIS can transform to support 3D, and there's a lot of different ways in which we're seeing that already in the market. I'm Philip Melke. I'm the 3D Web Experience Product Manager, and I'm joined here by Steve Heidelberg, who is the 3D Core Product Manager. And we'll be going through a big discussion today over how visualization improvements, content management has improved, and how we can ultimately distribute through applications in WebGIS with various analytical techniques and a variety of new data types that you can take advantage of. Now, to begin with, what I wanted to share with you is a safe harbor statement. Ultimately, this is a forward-looking roadmap here, and we want to make sure that you're aware that these are some of our priorities and our scope, but some of these things can change without notice. So this is just a way to ensure that you're aware of this is what we're working on. In some cases, really a majority of this is what we've released, but we just want to make sure that you're aware that this is these are a lot of forward-looking statements here. But to begin with, what we'd like to discuss is the reasons why. Ultimately, reality capture and design and engineering data, there's been an explosion of new types, methods, sources of 3D data, and different variety of collection methods. We're seeing LiDAR from drones, photogrammetric point clouds. We're seeing terrestrial LiDAR based on trucks or backpacks, airplanes, satellites. There's high-resolution global scale meshes that are created from aerial and satellite imagery, spherical and oblique imagery from consumer and industrial devices, and we're also seeing an explosion in underground information from millions of boreholes. And all of this can be processed and interpolated in ways that it's really exciting. We're seeing new ways in which GIS is being approached using that third dimension. There's also large imagery processing pipelines from Vexcel, Harris, and others. And we're also seeing a lot of good improvements in terms of IoT and the way that indoor location is used for a variety of different use cases. So this kind of data availability is of new types and new data sets is really driving the demand for new experiences. We've seen many of the sessions here in 3D that were absolutely packed for audiences, like with the AR, VR presentations, and we've heard that many users were already being asked about creating new experiences for their customers using Esri 3D content. And we've seen expectations from consumer markets like the gaming community that infiltrate professional software the professional software product industry. And we're seeing that with VR and AR, and we're seeing this with game engines, and the level of spending on VR and AR and game engines is really escalating rapidly. And we've not quite really figured out exactly how it'll impact GIS, but we're seeing a lot of different ways in which it's starting to now. So we look at user expectations for new types of GIS experiences, and we see that they're driven by a lot of these adjacent markets, like the consumer domain or emerging data analysis industry tools. And what we've observed is that 3D is becoming a unifying, common visual and analytical experience for GIS that merges all of these experiences. So the value of 3D, they're not just adopting it because it's new or because it's pretty. They're adopting 3D because it has intrinsic value. So to begin with, there's a more accurate representation of the real world. Measuring in 3D is different in 2D. And we have the ability with 3D to communicate with non-technical stakeholders in ways that are intuitive, that we haven't quite seen. We haven't seen the way that people respond to 2D the way that they respond to 3D to understand the locations of things. It's immediately recognizable, intuitive, and it's an exciting experience to navigate within 3D. We have the opportunity to be able to visualize features that don't exist, like thematic extrusions or space-time cubes, or things that can't really be seen, like underground features, like this example here with boreholes and microseismic activity. We also have the ability to analyze behavior and aesthetics with a new dimension here, being able to extrude data, visualize in new ways, and really produce some exciting experiences for your end users. So ultimately, 3D is just 3D GIS is just GIS, and it's supported across the platform. And this presentation is going to go into depth as far as what that means and how. Ultimately, 3D is a web GIS services-based architecture, just like what you're used to working with within the ArcGIS platform. And we have new clients and experiences that we can work with here within 3D. The things that we'll see, like Experience Builder, that's emerging, and we'll have other examples here with new clients and experiences with ArcGIS Pro mobile applications, Pro Mobile, and we'll have workflow modernization techniques that we'll share in terms of content creation and data management. And there's story-based solutions and products here, geo-enabled systems that Jack talked about earlier in some of the sessions, as well as SUD. These are ultimately driven and developed with the 3D architecture in mind. 3D GIS will produce a complete workflow for managing, publishing, sharing data in 3D. And to begin talking about this, we're going to start first with some of the visualization capabilities that have improved here over the last year and share some examples as far as what that means. So I'm joined here by my colleague Steve Heidelberg, who will now be able to talk to us about some of those visualization capabilities.
Thanks, Phil. That was great. I'm going to talk about what we've been doing over the last couple of years in regard to visualization. In the past, when creating 2D points, lines, features, and so forth, 2D symbology such as billboarded images were valuable in creating your experience. But as you know, with 3D, there's an extra level of complexity, and we've been wanting to enhance this over time so we can provide you a full set of workflows that let you display your GIS data in the best light possible for these 3D projects. And I think the work the development team has been doing over the last several years is really going to let you light up your workflows in a way that's efficient. Some of the areas I want to highlight that I'm going to discuss over the next couple of minutes are our abilities to do animation and temporal data has improved greatly. What you're seeing on the screen here was actually created with all of our animation tool sets in ArcGIS Pro. And I really think it highlights some of the workflows that you're capable of doing right now. When I first started Esri 5 years ago, a lot of these things just weren't possible. And I feel like you can do it much easier these days. So we're also doing display improvements. With every year, our graphics has improved. Virtual reality and augmented reality solutions. We have some products currently available, and we're going to continually build these out. Additionally, game engines, which help you create these VR and AR environments. We're starting to build a bridge or integrate with common game engines such as Unity and Unreal. And then lastly, graphic power and performance not only improves in regard to hardware, but our tools overall have improved every single year. And I think you'd see this in how quickly you can work through creating complex 3D GIS content. So what does this really all mean? We really just want to make your 3D projects or maps more visually appealing. So how things look is essentially important. Some of the things that we're doing in regard to display improvements to make this happen are shading and ambient inclusion. This essentially is the overall lighting model. So the lighting model for 3D maps or scenes has improved dramatically. If you look in the lower right-hand corner of the slide, labeled ambient inclusion, you'll notice that the city is bright in the foreground and dark in the background. This is due to ambient inclusion. It provides a greater deal of depth to a 3D scene, makes it overall just more immersive. And then PBR, or physically based rendered materials. Right now, we currently have reflection, transparency, and specular highlights enabled within our toolset, and we're going to continue to build these out. If you look in the lower left-hand corner, the movie labeled GLTF of the SWAT car or police car, you'll notice the specular highlights rolling across the paint. It's really showing the detail level that these physically based materials highlight. So you can see the displacement or bump map on the paint itself. And it just brings an extra level of detail or complexity to your projects. And then lastly, you can consume, and in CityEngine, you can also export GLTF models. So in this example here, it means you can go to a common marketplace, as I did, such as Sketchfab, download a GLTF model, consume it, not have any understanding really of how it was authored or modeled. You don't have to have a background in building materials or textures. And GLTF ensures that you can consume it and just display it as it was built. So to reiterate some of the things we've been talking about, ultimately we're improving visual aesthetics across the platform so you can highlight complex data. 3D GIS content tends to be complicated. So we've enhanced lighting overall by improving iDome lighting for LAS or LiDAR data. Essentially that means when you're looking at millions of points regarding LiDAR data that it sorts properly, that it stays in place properly. In the past it might have popped in and out a little bit, and now it doesn't. And that just helps with the immersion of the 3D scene. You can also colorize your LAS data. So essentially LiDAR data can come in almost like a neon color mix that's categorized where a user might not understand what they're looking at, and you can immediately absorb the base map or tile colors and push that into your LiDAR data. And that's what you're seeing in the movie in the lower left-hand corner. We have water, so animated water, you can change the states of them. You also see within the movie here that we have reflection. Overall, better visualization and workflows with symbology. This is something I wanted to highlight because I think a couple years back it was very difficult to build a synthetic environment on top of an accurate GIS environment. And I feel like the tools and workflows in place now really enable you to do that rather quickly. In this project in the upper right-hand corner, you're seeing a number of 2D symbology mixed in with complex 3D models. And then lastly, stylized content. Oftentimes GIS data can be gray, or the buildings itself can be shaded just in pure whites, and they don't really highlight or jump out, and you can actually view them now in stylized content such as sketch edges and solid edges. This will give you almost like a draft mode, or it'll make it look like it's been inked over. We're integrating and building bridges to game engines. So we're doing this with common game engines like Unity and Unreal. We have a game engine SDK that was highlighted in the plenary. So that SDK is available both in Unreal and Unity, and that's going to be something we continue to build out. There's City Engine and VR workflows such as City Engine VR Experience, which is our premium VR app, integration with Unreal and Unity. And we're doing this by enabling you to go into City Engine and export the Datasmith format, and then also publishing the VR and AR very easily. So some of the virtual reality products that we have available are making this much easier for you to create these VR and AR experiences. In the past, creating virtual reality applications was something that was complicated or difficult to do, and I think some of the products that they've put into place have made it much more accessible to everyone. ArcGIS 360 VR is one of these products that has a low barrier of entry, and I think it's great if you don't have a lot of experience either in authoring VR app or viewing it, that this is a good place to start. Because it's lightweight, it's mobile, you generate your VR via hotspots or bookmarks and essentially tie these bookmarks together. The advantage of doing this is you eliminate motion sickness, and that's something that's common in a lot of virtual reality experiences where you can walk seamlessly from point A to point B. And with hotspots, you actually teleport or jump into locations to some degree. And then these hotspots are enabled through City Engine's proprietary format of a 3VR. It's a 360 image that's essentially taken for each of these, and they're tied together. And lastly, that's very accessible to everyone because it's accessible to a cheaper cost such as Gear VR. There's also City Engine VR Experience, which is our premium app. That's set up for HTC Vive and Oculus Rift. It enables you to create a tabletop AR experience. Some of the things that it brings to the table currently are improved interactive tools, so you can do line of sight and then also measuring. There's improved sun positioning. You can change the time of day, and there's also improved lighting. And lastly, realistic water animation. In the lower left-hand corner of a slide are a couple of links that you can explore if you want to learn more about the City Engine VR experience. And then lastly, ArcGIS Runtime lets you create custom experiences. It lets you take advantage of device sensors, transparent backgrounds, so you can lay on top overlays and 3D images to your camera feeds. And then lastly, stereo display. Animation and temporal visualization is a workflow that has been extending quite a bit over the last couple of years. Some of the things that I want to highlight that have been improved are display path and function curves. This enables you to actually change your camera path by visually seeing it on screen. It's something that's very common in a lot of very high-end 3D packages, and it's something in our tool set as well now. Time and range slider, so you can not only discover patterns, but now that you can also record them in regard to temporal data. Animation of exploratory analysis tools. This means you can animate things like view sheds and line of sight and so forth. Publishing to many media formats, so MP4s, AVIs, and animated GIFs, and then finally letting them be consumed in common places like YouTube and Twitter. ArcGIS Earth also is something I want to point out because they have an extended animation tool set that's to some extent not even available in other tools. If you look in the lower left-hand corner, you can animate symbology and attach exploratory analysis tools such as viewshed or line of sight. And I think the combination really lets you add a lot of value to your analysis. Lastly, I want to point out enhanced performance overall throughout the platform has dramatically improved, and you can see this in the movie here. Excuse me, I'm just going to take a sip of water. In the upper left-hand corner, you have old uncached, and you notice it's slowly drawing in. Lower right-hand, you have new and cached, and it immediately draws in. So essentially what this means is large 3D data sets such as I3S and BIM can be viewed in an efficient and interactive manner. You can do interactive analysis in a more efficient manner and so forth on these 3D sets. And then lastly, shareability is much quicker in environments like AR and VR, and lastly, rendering of movies.
Well, thanks, Stephen. I'm going to give a quick overview of some of the 3D analysis capabilities that have improved over this last year, just to give you a sense as far as what tools are newly available to you, if you're familiar with our platform for 3D analysis. So to begin with, some of the components that have improved recently around 3D analysis are LiDAR classification and those supporting tools that help to make that part of the workflow a reality here. You'll notice in the Pro toolbar, there's for LiDAR data, there's automated classification UI that's available to you. And these essentially trigger some of the geoprocessing tasks that enable you to work through a stepped method of classifying LiDAR data. Beginning with the ground, you can then classify buildings, overlap, noise, and height, vegetation by height better, so that you can ultimately end up with a series of classification values that you can then use as a method of visualization both in Pro and on the web. You'll also have seen the example of the profile view tool that gives you the opportunity to be able to immediately move your view pane to the side, and so that you can look in 5-meter increments and see the height values, and it'll give you the opportunity to be able to pick out individual points and classify those there. Also available is feature proximity, which is helpful for the classification methodology here, so that you can identify features that may be like power lines that have some form of proximity to other features that can give you a sense as far as how to both select and classify. And finally, new here is the ability to colorize LAS data, so that you can go from this symbology set for LAS that first was colored by elevation values, but you can use orthophotography in order to be able to colorize that point cloud and ultimately give you a layer that you can use for really realistic visualizations in 3D of that LiDAR data. We also have 3D analysis, exploratory analysis tools that are available across the platform. You'll see here in the table, we've got Pro Earth and the Scene Viewer or the JavaScript API. You can find all of these exploratory analysis tools in Pro, but you can also find them. You can find them here within Earth and Scene Viewer or the JavaScript API as well. New to the JavaScript API is the ability to run line of sight analysis tools. So that's in our developer portal. I suggest you try the example that we have in the sandbox there, and you can get a sense as far as how the performance works for this. It's a really exciting experience here. And so with this, I think Stephen's got a quick demonstration here of some of those exploratory analysis tools.
Thanks, Phil. What we're seeing here is 432 Park Avenue in New York. We're going to go ahead and try to establish how much some of this real estate might cost. As you know, in New York, what you can see from your window is very important. So we're going to utilize a view shed. We're going to take a bookmark and line up our site to the window itself. Create a view shed now. And I'm going to do this by going to Observer from Camera. This creates it from my point of view. I'm now going to go to Properties and extend my maximum length to 1600. This is going to let us see the entire park. And now I'm going to pull the camera out, take a look at what's visible. As you can tell, some of the front of the park has been obstructed. That's indicated by red. The green is the visible area. And so if you wanted to maybe view the zoo that's at the front of the park, this would be a problem because it's obstructed. Also, I want to note that you can make changes and interactively updates very quickly. So now I can extend it and see the front of the park in its full entirety. So as we can see, the park itself is, for the most part, visible. And now we're going to take a look at an intersection in Redlands, and we're going to establish some views of the cameras, the traffic light cameras, and check the visibility across the intersection. I'm going to toggle on a replacement object for the intersection here, and then I'm going to create a couple view sheds based upon points that have data set up in the attribute table. So right now I'm going to go ahead and select a layer with the points associated to it. These are camera view sheds, and it generates 2 of these, and it's showing that the coverage right now is limited. I can also utilize the range slider to play that back and check the coverage of a car as it passes through the intersection. So once again, the way this works is it's indicated by colors. Red is areas that are not visible to both cameras. Green is visible areas, and then there's a slight sliver in the center, which is yellow. That is overlapping content. So that is the most visible area. That's overlapping regions of the cameras. I also want to note, as I make these changes, you're seeing updates immediately on screen as well, so I feel like it's very responsive and interactive. And as I go ahead and I tilt those cameras down, you notice that the overlapping regions now are larger, and you're getting more coverage overall from these cameras. So this is a very useful tool for ViewShed in that you can set your camera's angles quickly. Next, we have Slice. Slice is really useful for looking at complex 3D data, such as BIM models. Oftentimes, you can't view the interior model, such as like with a BIM model, there's interiors set up, and Slice lets you actually cut through these objects very efficiently. So here I'm just taking the slice object and I'm only temporarily slicing through the building and showing the interior components of it. Once I go ahead and delete this analysis object, the mesh will return back to how it was, so it is only temporary. I also can go ahead and create a volumetric slice as well. I'm going to go ahead and create a box slice here. So I'm going to just be looking at a subset of the building. This is really useful if you only want to highlight a particular region. So in this example, I'm only going to look at a particular room. I'm going to scale the box out to highlight just certain regions of it, and it's only going to cut away a subsection of this building here. I think this tool is really useful, not only because it's highly interactive, but because it's just easy to execute. Lastly, I'm going to show you ViewDome in conjunction with the animation workflow. I think when you start to tie in exploratory analysis with other tool sets, such as animation, you can come up with some interesting results. So here we have a presenter. He's I guess, a potentially soft target to an IED that might be behind him, an explosive device that's on the street. And we want to see what type of impact that might have because of the tree opening in the park here. So we see that it actually is hitting the audience and the presenter. So we're going to enable a barrier. And now, because we have some keyframes already set up with the exploratory analysis tools, we can drag in the time slider and see if this barrier is now protecting the audience. And once it loads up, it'll go pretty quickly. So it'll you'll need to give it a couple seconds, but once it comes into place, we'll be able to play it back in near real time. And as you notice, the barrier already is showing that it's covering the presenter and the audience quite well.
All right, great. Thanks, Stephen. All right, one more piece of analysis that I wanted to cover here was some of the improvements over 3D empirical Bayesian kriging. And we've seen a lot of interesting workflows with this so far, with scientific data, oceans and atmospheric data, the ability to be able to interpolate and potentially predict some subsurface geological properties. But the example that we're seeing here is based on interior positioning breadcrumb data within a five-story building. And what we're able to see with this is really a sense of presence with all of that tracked data here. There's over 200,000 points here that end up creating essentially this version of a 3D hotspot map, so that you can get a sense on where it is that people who are tracked with the IPS device, where congregation is occurring. And this can really lead to some really interesting workflows in the future, then to be able to export this data in a variety of different ways, or to then be able to understand where people are congregating for examples of site security and risk mitigation here. Really think it's an interesting workflow to try, and really all it requires is point data with values inside of it. So it's worth a shot here. Also, I want to bring up some 3D solutions here. So the solutions team has been hard at work to find industry-based analysis that ultimately creates data or analytical products that can be very useful for all of these individual workflows in the process of creating data as they're needed. So first, the 3D local government base map solution starts with some very basic data types, aerial LiDAR and footprints. And from that, you can derive realistic LOD2 buildings with appropriate roof forms and schematic vegetation, so that you can already begin using some data that many local governments have in order to start your visualization process and working within 3D. Next, 3D tools for power lines is a great example to use the procedural runtime tools to start with some lines and some points and some data, and essentially develop these 3D power lines that can then be used to identify examples like encroachment, so that you can identify line sway and determine where you may have vegetation encroachment from LiDAR, and help to mitigate that, so that we can ensure safety in delivering power to customers. Another example here that's just released is the 3D flood impact solution. It's a combination of a pro task-based workflow that will generate multiple scenarios for the potential flood rise, and with that will also identify what infrastructure and buildings have been impacted in the process with a web application here. And additionally, visibility assessment solutions is very helpful in real estate and public safety markets, where you need to be able to quantify visibility across larger areas, where you have a larger observer area and a larger target area, and in that you may have a series of obstructions along the way. And it will give you a sense, a tiled output that helps you to identify what the total quantified visibility, in a way that's a little different from some of the exploratory analysis tools that we've seen, as most of those exploratory analysis visualization tools work from a single point of observer. So moving on, there's been several improvements that you should be aware of, and this is a great basic overview around 3D content creation, editing, and data management functions. And so the ArcGIS platform really enables this process of being able to deliver distributed GIS. And part of that is in following with the concepts of distributed collaboration. So distributed collaboration is not a new concept to the ArcGIS platform. It's just that now 3D data is supported within the ArcGIS platform for distributed collaboration. And essentially what happens is organizations, ArcGIS Online organizations and enterprise organizations can share groups of 3D content that enable workflows and collaboration in ways that are really exciting to see now. This is really useful, I think, across the 3D space, as cities, architectural agencies are really looking to determine what's the right way to securely share data. A lot of the information that we're talking about, if it's either the consumption and the showing of building scene layers, may be of a more of a concern in terms of safely sharing that kind of data. And this gives the opportunity opportunity to establish that kind of trusted connection so that all of the data that we may be sharing can be shared in real time, and ultimately there's a common operating picture between agencies that have established this kind of trusted connection. And as I was mentioning before, it can work by reference or by value, ultimately producing copies of data or referring to individual pieces of data, so that a good example here, a land records agency may be containing and storing a building scene layer that is referred to by multiple agencies here, a construction group, public safety groups that need to ensure the safety of that area, municipal engineering who may be working through development impact fee assessment or identifying how it is that they can connect some of the utilities in that city, all through secure and trusted distributed collaboration. Another example that we saw at FedGIS just recently is that we have a business partner, Innovate Solutions, that's working with both the EPA and the California Department of Toxicity Toxicity and Control Board, that is ultimately working at developing and understanding underwater pollution plumes, or underground pollution plumes. And the way in which they're establishing that kind of connection is through distributed collaboration, so that ultimately that partner can establish these information products and share it with multiple agencies in a way that enables how they communicate with each other, while at the same time this is sensitive information that they wouldn't necessarily want to be able to share with the public. So I encourage you to check out distributed collaboration, especially if you're new to the ArcGIS platform, as a mechanism for not only collaborating but delivering and distributing information products. So next we're going to take a look at the concept of I3S scene layers. And scene layers is the mechanism by which we're able to author and visualize these large volumes of 3D content. And we'll share some examples of this, but we've seen this improve just greatly over the last year, both in terms of performance and how the workflow is managed. We're going to talk about a couple of those pieces there. And so it's just really exciting to be able to see an entire city of data streamed to a mobile device in a way that's very performant, that scales well so that there's multiple levels of detail that are showing at the appropriate times, and that you can also share these new data types through this mechanism. So the scene layer package, as we've seen, is also a very good mechanism for being able to deliver these kinds of data types from organization to organization, and ultimately this is how a lot of the complexities of some of these 3D scenes that we'll be seeing have been distributed. A little bit about the life cycle of this. We have several clients that can author this. Pro, City Engine, and there's a variety of our own third-party vendors that are creating I3S content. And with that, then they publish it to, you can publish via ArcGIS Pro to ArcGIS Online or to ArcGIS Enterprise as a web scene layer from that individual scene layer package. And you can publish on ArcGIS Online as a hosted web scene layer from a feature layer. Or you can upload an SLPK as a mechanism to ArcGIS Online and Enterprise that will then publish directly there within either Enterprise or Online. And I3S can then be consumed by a variety of clients within the ArcGIS platform. This is intended to be a common mechanism by which we're able to share share and stream this large volume of 3D content. So clients like ArcGIS Pro, obviously. Web Scene Viewer is also one of the primary mechanisms by which our clients or our customers are able to consume I3S content. But also ArcGIS Earth Runtime and ArcGIS Earth Mobile are all really great ways to be able to consume some of that I3S content and be able to stream it over to these clients to be able to view the same common experience in working with that data. And then on the other end of this, what we'll feature is a maintenance workflow in which ArcGIS Pro is able to update and work with update these scene layers and provide a mechanism for keeping that data current. So just a few examples of what these scene layers are, the different scene layer types. This is an example of a space-time cube that was created to show monthly water consumption within Redlands. So it's a visualization technique that we're showing the smart mapping controls that we have within Scene Viewer to be able to identify or to visualize those attributes that we have there. It's a bit exploratory here so that we can review a couple of these different kinds of color ramps here, find the right way in which we want to be able to show this data. But all of this is happening through the point scene layer. The point scene layer is an optimized streaming experience for a large volume of point data that have the attributes that this smart mapping technique is relying on. And in the lower left, you'll also see the point scene layer is been featured by NASA recently as they're sharing a smoke plume model from the Australian brush fires. 3D object scene layer, this is one of our more common types and one of our earliest types. We're able to stream, as you can see, all of New York City here within the Scene Viewer. And what is barely noticeable here at this point is the switching LODs and the ability to be able to bring all that data in at once and visualize it so that it ultimately makes sense for your end viewers. So this is a great mechanism. You'll see this going from multi-patches to these 3D objects. And again, it's our most common type. It's probably one of the first types that you'll create if you're new to 3D GIS. So point cloud scene layer is how we deliver photogrammetric point clouds and LiDAR data. And we're able to stream really terabytes of information here to enable how a web client can ultimately view what was previously impossible to easily be able to change how we're visualizing, how we're classifying that data, or how ultimately we're delivering this kind of experience. And so what we're seeing here is aerial collected LiDAR here in the video, and also in a terrestrial LiDAR example here too. So the point cloud scene layer ultimately gives a great mechanism for being able to share large volumes of LiDAR and photogrammetric point cloud content. One of the next content types here is the integrated mesh scene layer. And this is that combination of elevation and photographic data that have been combined here to be able to give a skin of the earth model that is streamed very well, and you can really get the impression as far as a reality capture technique here, so that we are able to use this as a common base map. Now, new to Scene Viewer is the ability to drape features to mesh, so that you can essentially do some marking up for a variety of different workflows. If this is either tactical operations or you have some special event planning that you need to do, placing features within this integrated mesh is a great way to understand how you can derive value from this and use this as a planning resource as you're moving forward with some larger scale plans that require the context of 3D. And one of our more recent types of scene layers here is the building scene layer. And what we're able to do is to consume data from Revit as a data source in ArcGIS Pro, and then publish this as a building scene layer. This example here is covering a college campus with we have over 90 building scene layers that we're bringing into a scene here, and able to show the complexities as we slice through this building scene layer to view this building, to see all of the features that were planned in that architectural model, and then really begin to use this data as that empower a series of different kinds of experiences. Working with this gives the opportunity to be able to manage or as an input for products, geo-enabled systems like indoors, or other kinds of viewers that you may use for like work order systems or IoT within buildings. It's a great start to begin to leverage, and we're seeing the explosion of the publishing of this, and this is happening more and more frequently here. So the building scene layer is a great new way in which to approach 3D. So on with content management here. We have a workflow that's associated with the maintenance process for being able to keep that scene layer up to date. And ultimately what we have here is an association. It's a scene layer with the associated feature layer. And what that means is that that feature layer becomes that editable resource that then we can update those components within the scene layer. So this workflow as it begins is that within Pro you enable that editing so that you're able to edit those feature layers both within Pro, and soon, as we've seen here, we'll be able to do this on the web, to then be able to edit attributes, edit geometry, and then rebuild either fully or partially components of that scene layer so that it can then be updated and consumed within those clients on the other end. So that this rebuilding process is something that happens online, and it also we have some new capabilities here in which the partial updates process, which avoids the rebuilding of a full cache of the scene layer. And that helps to reduce time as you're working on individual aspects, or if you may just say be editing attributes on a single building, it keeps that part of the workflow from being both a time intensive and a processing intensive piece. Something we have coming soon here is the building scene layer with associated feature layer. So the complexities of that architectural model that I shared before as a building scene layer is something that you'll have full control over, so that you can change things like with room assignments or attributes, or even the geometry here with that associated feature layer, and then publish that for the consumption in other places. So feature layers still have a place within 3D, and some of the things that we've been seeing recently as far as how this is enabled is the ability to be able to work with a variety of different new smart mapping styles. Having a really useful feature here is the ability to have your existing building footprints with height data immediately extruded here within the scene viewer, so that you can just all at once start with your visualization of buildings within 3D. And one of the other components here is the ability to use lines as a method of being able to extrude those lines to reflect things like utilities underground. And this type of extrusion can have a variety of different forms, if it's either a tubular extrusion or a rectangular extrusion, or we can also make walls with those feature layer lines. Now, a great thing about the use of those feature layers is that it's the same feature layer types that you're used to consuming within 2D. So organizations that are reflecting their utilities, for example, can now have the ability to work with those features in real time and represent those as 3D within a scene simultaneously. So updates that are being made to that authoritative feature layer now can have this kind of reflection and contextualization within 3D. One of the other improvements here is the way that we've enabled water styling for the web. And as you can see in the lower left-hand example, this is a simple polygon feature layer that's representing those that water feature. And in this we have both the animated water styling and the reflection from that light source of the sun, so that we can really get a sense of realistic water visualizations. It can be useful for things like visualizing floods with the flood impact solution as we move through multiple scenarios, or just one of those things to really dress up that scene. So one of the other great things about feature layers and the use in 3D is the ability to use that real-time data. So a refresh interval can be set for the feature layers that you're consuming from, say, if it's GeoEvent Server, analytics for IoT, any other real-time data sources, and those data sources will update to reflect that within the scene view that you have. So utilizing that feature layer just in Pro, Scene Viewer, or other clients, you can ultimately be able to see things like this interior positioning example, where we're seeing web-styled points move to reflect the current location of individuals that are moving throughout this building here. One of the other components of note here is how feature layers are web configurable, so that you can, within the item visualization tabs, you can configure pop-ups to show things like traffic camera feeds. You can show 2D billboard symbology choices like Firefly, or utilize 2D smart mapping within the 3D environment. You can also utilize 3D or multi-field filtering, extend filtering, and then establish that refresh rate there for like that example that I just showed with live data. So we have a few new editing improvements here with Pro that I wanted to focus on. The ability to explode, which will separate multi-patch features into those individual 3D faces, and merge will also give you the opportunity as an editing workflow to combine those individual multi-patch features to a single feature at this point. Slicing multi-patch is a great way in which to, say if you've got a large building that you want to break into individual pieces, it's a great way to use a vertical cutting plane in order to slice that up. And we also have a few improvements with some extensions, the Parcel Fabric 3D API, so that we can accurately reflect ownership within 3D. And as a lot of our customers have asked for, so that you can show ownership of multiple floors of complex buildings. We also have a tin editor and feature templates for multi-patches to be able to drag in primitive features and work with those as a starting place for being able to create your 3D content. Also new, as you've seen on the plenary for the Dev Summit, is the ability to edit 3D editing on the web. And this is really exciting. It's a core capability to edit first our point line and polygon features in the scene. And we're moving on to being able to place and manipulate 3D models. But this example here of a participatory planning app gives you a sense as far as what that experience can be like. Either the ability to draw draped on the ground, these 3D features that are already programmed to be extruded, or to work through some pretty complex 3D editing components too, like placing 3D points in the air at specific areas. The editing on the web is just new, but we're really going to get an exciting sense as far as how our partners and our customers are going to be able to use this feature here. And I'd be remiss to not mention KML editing in Earth. This is also something that is relatively new to the ArcGIS platform. The ability to use KML really as a data source, and not only as a data source, but as a data as an authoritative source that we can then manipulate and then distribute for other clients that are expecting or are used to working with KML data. So this is a great example here of showing this process of working within KML editing within Earth. Also new is the mobile scene layer, or the mobile scene packages. And what this ultimately means is a clip and ship workflow to be able to package all of this data into a single piece that can then be distributed to our mobile clients. So using online and enterprise as a distribution mechanism, Runtime and Earth Mobile can consume these packages in order to use all of the supported source data sets in order to be able to visualize these complex scenes within disadvantaged or disconnected environments. So delivering all of these things is a line of ArcGIS products. And we wanted to save this for the end, as this is a focus on the 3D capabilities across the platform. And these are the individual products that help to support those 3D workflows or ultimately consume those. So first, I'd like to hand it over to Steve to discuss Pro.
Thanks, Bill. ArcGIS Pro is our premier desktop application. I'm going to highlight some of the things that have been improved over the last few years. 3D editing and modeling, you're able to directly edit OBJ, DE, and multi-patch features. This means that you can not only author, but you can also edit these in application. You can view exploratory analysis tools such as line of sight, viewshed, view dome, and slice by plane or volume capability can be applied to the visible scene layers. Additionally, cut and fill is a new feature. You're seeing that in the lower left-hand corner of the slide. Once again, these are all highly interactive, and then also you can animate these. As I was talking about earlier, realistic visualizations is something across the platform that has really improved. But I want to highlight in ArcGIS Pro that there's been a lot brought to the table that lets you look at your GIS content in a more compelling, more detailed way. Things like ambient occlusion or the overall lighting model has been improved. That includes iDome lighting for things like LiDAR. Material support, so that's the physically based rendering or materials that support reflections and specular highlights and so forth. That's something that we're going to continue to build out into the future as well. And water fill symbol, the ability to display realistic water and also change the states of the water, so it can have various different ripple or wave states. 3D object scene layer symbology, smart mapping functionality to stylized 3D layers, similar to the web scene viewer. Animation for static and dynamic storytelling. So you can create rich animations and share these on popular formats such as YouTube through MP4s and AVIs and so forth, and really any other social platform that can consume these file formats. There's a number of file formats either through movies or images, and then also you can animate temporal data as well. And then lastly, last classification. So you can classify building rooftops, ground and vegetation LiDAR, and then new profile viewing helps manually classify LiDAR. Next up is City Engine. This is our premier authoring tool that lets you procedurally build cities, rather complex cities. And I'm going to also highlight some of the things that have been taking place for City Engine. In addition to not only being able to procedurally build and author these complex city environments, you can do quantitative visibility assessments. So a lot of the exploratory analysis tools that are available in ArcGIS Pro and other tools are also available in City Engine. Things like the viewshed, which you're seeing in the lower left-hand corner. You can evaluate your city by analyzing it with these tools. So you can do detailed statistics, have been added to viewshed and viewdome that quantify visible qualities. Additionally, you can import and export GLTF. In ArcGIS Pro, you can import GLTF, but in City Engine, you can do both. You can export as well. These are the models that contain physically based materials, and in the future, they might contain other things as well. Web publishing of elevation data. Export a terrain layer as an elevation tile package that you can merge with Esri's World Elevation Service. We're also building a bridge with Houdini. So City Engine has a plugin to Houdini, which is a high-end 3D application that's often used in visual effects and has very advanced simulation and modeling capabilities. So if an artist is working in Houdini, they have a pathway now to utilize City Engine. And then CGA operations for urban design. Clean up inaccurate building footprints, control setback distances, and enable better encoding of urban design practices. And lastly, as I was talking about before, there's a bridge to build premium VR experiences as well. So there's 2 new templates for the Unreal Engine for real-time visualization, and it lets you create a AR tabletop experience.
Another one of our products, Scene Viewer, is the mechanism in ArcGIS Online and Enterprise by which we're able to view and to work through these rich experiences within 3D online and via Enterprise. There's been a lot of new improvements for this. This is both the mechanism by which people author scenes, bring some data together and create these web scenes within an environment that is ultimately distributable to a variety of different applications, just like web maps are. But in that, as we've shared before, automated water visualizations, and we're able to show large feature data sets where feature layers have been, there was a limitation that was removed for this, so thousands of feature layers can be added to a scene. The smart mapping line and polygon styles, as I shared before, and also the ability to search for feature layers in web scenes. So this is one of those mechanisms by which you can use that scene layer with associated feature layer to be able to find a searchable index for those features that can make some otherwise hard to find features immediately navigable and discoverable. New to the experience with building the building scene layer is the building explorer, which is the UI that's associated with that building scene layer, is the ability to pick individual floors and individual phases of the construction process to then be able to visualize that. And also worth noting is the ability to navigate underground so that we can explore that subsurface geology and infrastructure in a way that is really exciting. It opens up the way in which some industries are working within 3D. So I also should mention ArcGIS Earth here at this point, which is a lightweight free client that can be used and implemented in a variety of environments here, so that it's a lightweight viewer that makes it easy to be able to have this kind of immersive experience that also utilizes all of the data content that had been created before within your organization, so that we're able to distribute and interrogate that data for a variety of geospatial workflows. Also in here is new to this is the ability to save out KMZ files and to do some of that editing. And we can also use exploratory analysis within Earth, especially the line of sight and viewshed modeling. Also relatively new to Earth, you should be aware that there is a mobile application that's associated with Earth, ArcGIS Earth Mobile, that you can use to, as I mentioned, review those mobile scene packages or to access all of that information that's stored within your enterprise. So there are apps on the other side of those scenes that you may be creating within your organization or your enterprise environment that can then consume those web scenes. All of these apps are associated with 3D tools that can then be used both for the field, in the case of Drone to Map, where we're collecting information from drones and developing a integrated mesh and other 3D products like an elevation layer. We can use Web Scene Viewer to be able to distribute 3D maps and experiences that with associated widgets and workflows, so that we can ultimately have a very bespoke app building process that will then give you an application that can be consumed for a very specific piece of the workflow. We have app templates, like an example that I have here is the scene with inset map that helps users to orient themselves with where they're looking within 3D with an associated web map and the location of that camera viewer on that web map, so that you can ultimately navigate in 2D and 3D at the same time and be able to really get a sense of where you are. Other things, story maps. So the new story maps uses, you can bring scenes in order to drive some rich experiences. And Experience Builder, which is also newly released, is this ability to really bridge that gap between 2D and 3D content. And you can also have a very similar authoring experiences where you can drag and drop widgets. I've seen some of the new widgets here. I'm really excited about this fly and turntable capability, where you can ultimately park a viewer at a certain point and then turn the scene around and have it rotate for that specific view. So there's a few geo-enabled systems here that utilize 3D here as the premier environment by which we're able to share and develop some of these workflows that help to support individual industry-based kinds of planning workflows. ArcGIS Urban here is a mechanism by which is a geo-enabled system by which we're able to develop projects, plans, and indicators in order to work with stakeholders to identify and develop these scenario-based modeling for how cities are ultimately built out. Other opportunities here with ArcGIS Indoors. Indoors, as you may be well aware of, is a geo-enabled system that really brings together the facilities, the management and visualization scenario, so that wayfinding, interior positioning, operations like safety and security or emergency management, asset management, and space management are all contained within a single devoted geo-enabled system that helps organizations really with to reduce the inefficiencies that are pretty common in workplaces, finding where offices are, understanding how rooms are assigned. And there's a lot of these workflows that have been expanded, and as we'll see coming in 2020, where ArcGIS Indoors is headed. I'd suggest that you see some of these as we're planning for UC, space utilization analytics, assignment, office hoteling, hot desking, the ability to work with indoors online to be able to track assets and better inventory and inspection workflows. So to finish here, Steve, if you wouldn't mind covering then what's next for 3D here at Esri.
Sure, I think I can do that. So as you can see, there's been a lot going on for 3D at Esri. Some of the new capabilities that I want to highlight is KML refresh rate, 2D and 3D template, physically based rendering we were talking about with the material support, cut and fill and profile viewing, all the exploratory analysis tools, 3D line of sight in JS, and then slicing tool in the web. In the near term, let's highlight Earth Mobile. I think what's exciting is the voxels. I think a lot of people are going to find that pretty fascinating. The ability to potentially view complex data such as subterranean data and so forth is going to be driven by voxels. Mobile scene packages, as Phil was talking about, and then also reading Civil 3D. In the mid to the long term, ArcGIS for Revit, the voxel web experience. Another exciting thing is the transportation scene layer. We're going to continue to build on the interactive tool set that we have across the platform, and then 3D integration with IoT systems.
So thanks very much.
Thank you, that was great.